Our second method for identifying or balancing redox reactions is using what's called our half reaction method. Okay, and in our half reaction method, what we're going to do is we're going to break up our reaction into an oxidation reaction and a reduction reaction, balance each of them independently, and then rejoin our two reactions. So we'll look at this example. Okay, so the first thing I'm going to do is I'm going to break this up into two half reactions. And what I'm going to do is I'm going to take my manganese and any product with manganese in a product and put it in one equation, and my bismuth and any product with bismuth and put it in the other equation. Okay? Now, I don't know which one of these reactions is going to undergo oxidation or reduction, but I do know that any manganese has to be over there, any bismuth would have to go over there. Okay? And so this reaction now has all of the entities required to balance it except for oxygen and protons. So my first step will be balance everything except for oxygen and hydrogen. And so I have one manganese, one bismuth, one bismuth. Okay? And so I could place my ones. Now, in chemistry we know we don't write the ones, but I'm putting them for now just so that we understand what's going on. Okay, now I'm going to balance oxygen by adding my water, just like we did before. So here I have 4 oxygens, and I have no oxygen over here, so I'm going to have to add 4 water. Here I have 3 oxygen, no oxygen over here, so I'm going to have to add 3 water. Our next step will be to add our protons. So this is similar to what we've done before, except I've broken my reaction into the two halves. So I have 8 hydrogens over here, so I'm going to need 8 protons. 6 hydrogens over here, so I'm going to need 6 protons. So now my reaction is balanced based on mass. And by that I mean I have my conservation mass where my same number of atoms is on both sides of the reaction. What's missing though is balancing by charge. And so what I can do is I can look at the overall charge on both sides and I can balance it by adding electrons. So if I look at this first reaction, I have a charge of +2 in my reactants, and on my products I have 8 protons with a +1 charge and 1 permanganate with a -1 charge, so I have a total +7. I can only add electrons to the side that's more positive. So this side is more positive than that. So if I add 5 electrons, now the sum of the charges in the products are equal to the sum of the charges in the reactants. We look at this second example. I have a +3 in my products. I have a +6 and a -1. So I have a total charge here of +5. Okay, so I have more positive on this side than that side. So therefore, I'm going to add 2 electrons. So now, after I've done this, I can see this reaction has undergone oxidation because I have my electrons in my products. And I can see that my second reaction has undergone reduction because my electrons are in the reactants. Now, I want to combine these two reactions back together because I was looking at balancing my overall reaction. To do that, I have to multiply both reactions by some factor so that the number of electrons gained is equal to the number of electrons lost. So if I multiply my first equation by 2 and my second by 5, then my number of electrons gained and lost will be equal. So now my number of electrons gained and lost are equal, I can combine my two reactions. But if I'm careful when I line up my arrows, then I can use the technique we did in the Hess's law, way back in the thermochem unit, where I can cancel things out that are on both sides of the reactions. Because I'm going to add these two reactions together, but I have water in a reaction to this reaction and water in a product of that reaction. So therefore I can combine them and cancel out before I add them together. And I have protons and electrons and electrons. So I can cancel out my protons and I can cancel out my electrons. So therefore when I combine now, I have my reduced reaction. Now you could add it all together and reduce afterwards, but it's sometimes easier to do it when you're adding it together. Let's take a look at another example, but again we're going to do it in basic conditions. Now in this case, I only have one reactant, right, chlorine, but I have two different products. So what that tells me is one chlorine molecule is going to go under oxidation and one is going to undergo reduction. And one will undergo the reaction to form my chlorate and one will undergo a reaction to form chloride. So I'm going to write my chlorine as my reactants. Okay? And then now let's go through our steps. First thing, we balance non-oxygen, non-hydrogen. So therefore, I'd have to place a 2 in front of each of these. Now I'm going to balance my oxygens by adding my water. My first reaction doesn't need any. My second reaction needs 6 oxygens. Then I'm going to balance my hydrogen by adding protons. First reaction doesn't need any. Second has 12 hydrogens in the reactants, none in the products. So I'll add my protons. So now both of my reactions are balanced by mass. We have to balance by charge. I have 2 chloride ions with a -1 charge each, so I have a -2 charge in this reaction. So therefore, I have a -2 in a product, nothing in a reactant. So therefore, I have to add 2 electrons. And then my second reaction, I have no charges in my reactants. I have 2 chlorates with a -1 charge and 12 protons, so that gives me a +10 charge. So therefore, I have to add 10 electrons. And my sum of my charges will be the same on both sides. Then I determine my multiplier. So I'm going to multiply my first reaction by 5, the second by 1. So then my number of electrons gained is equal to my number of electrons lost. Okay, and then I can add them together, cancel out anything that can be canceled out. Okay, I can group my chlorides together. And in this case, I can see that I can reduce by a common factor of 2, so I will. Now, again, this is in basic conditions. So we have to go through and do what we did before when we have basic conditions. For each proton, we're going to add a hydroxide, but because my reaction is balanced, what I add to one side, I have to add to the other. Then my protons are going to combine to form water. And then because I have water on both sides now, I'm going to reduce my water, and then I'll just rewrite my equation.